So now it's recording. Oh. Why does this keep happening?
It's just like story with
Sad.
friends.
Okay. I'm just gonna switch it to yours.
Okay.
I think you can start.
I can start.
Mm-hmm.
Okay, hi guys, I'm Yana. I'm an iOS developer on AppDev, and I'm going to give today's lecture. Today we're going to talk about persistence, which is basically how you can get your data to be stored on your device between different app launches. So that way if you open an app again after you close it, that data is still there. So first we're going to talk about how we achieve persistence in iOS. There's a couple ways that you can do this, including user defaults, Codable, core data, CloudKit, and UI document. But today we're going to focus on user defaults as well as talk a little bit about Codable in the case that you want to store a custom object into user defaults. So for when do we use user defaults? You use user defaults when you want to save a small amount of data because it's kind of stored on the app. So some examples of what you would store are user preferences. So if you were to go into an app's settings page, like Google Maps for example, and you have your settings for the distance units like miles versus kilometers, or apps now have dark mode, so you toggle that with a switch, so it'll kind of save whether or not you want dark mode enabled in user defaults. And basically these all define how your app should behave when you start it up, and that's kind of where it got the name defaults from. So user defaults can be used to store a variety of data, and this data is going to be stored for as long as the app is on your phone. So if you were to open an app, change some settings, double tap and swipe up, and then open it again, that data is still there, but if you delete the app entirely off your phone, it'll be gone. And then user defaults can store basic data types very easily, so things like bools, floats, all the numbers, strings, as well as some more complex types like data, which is actually we're going to talk about a little more later, and we kind of cast or convert your custom class objects into data in order to get them to be stored in user defaults. And then you can also have date objects as well as arrays and dictionaries of all the different types that user defaults can support. So some examples of user defaults in some of AppDev's apps are transit on the left side. So we store your favorite destinations in user defaults. Like if you notice, if you add a favorite, you close the app and open it again, it's still there, as well as your recent searches. And then Eatery also uses user defaults as well to store the filters that you've selected, because on every app launch, the filters that are selected stay there. So there's a couple components or parts to using user defaults that are kind of key components to know. First off is setting up user defaults and its default values, storing data into user defaults, retrieving data from user defaults, and then we're also going to talk about using custom classes with user defaults in the demo. So to set up user defaults, you're going to create a user defaults object. So it's the standard user defaults object that allows you to interact with the default system. So you can access that object just by using user defaults.standard. And then we also use this register function to set default values for certain keys. So the way user defaults works, it's like a database that stores key value pairs. So if you see on the left-hand side of this dictionary, you have Boolean key. So that's your key, and then the default value that I've set for this key is false. And then you can see how you can also store strings as well as ints, among many other things. And the last example is a default value of an empty integer array. And then to store data into user defaults, if you're using the basic data types like strings or ints or bools, it's actually very, very simple. You just do user defaults.set, and then the way it works is you put the value and then you put your key. So your key has to be a string, but then the values can be various types. So I just set Yana for key name because that's my name, and then 19 for age because that's my age. And then if we go forward and try to retrieve this data from user defaults, you can use a variety of methods for that. So if you do user defaults dot, and your autocomplete will pop up a bunch of different options. So it's best to use the kind that corresponds to what you stored. So because the key name refers to a string, I'm using user defaults.string. And then it's always good practice to wrap it in if let in the case that it somehow fails to get this data from user defaults. So then you can see if I did user defaults.string for key name, name will now contain Yana because that's what I stored into it. And similarly for integers, if I do user defaults.integer for key age, you'll get 19 because that's what we stored on the previous slide. And then there's also a generic function user defaults.value for key, and that'll return kind of anything. If I could use user defaults.value for key name or age, it's just going to return the data in type any, and then you'd have to cast it into the type that you'd want it to be in. So if you know what it is, it's always best to kind of use the one that corresponds to it. Otherwise, you'd have to deal with casting. And then you can also use custom classes with user defaults. So the example I have here is a song, so kind of relating to the playlist player homework assignment. In order to use custom classes with user default, they must conform to the NS object protocol, and then they can also conform to codable or NS coding. We're going to talk about codable today because it's a little cleaner than using NS coding. Because it kind of, if you're only storing a type that has the default properties of like the basic values, so strings or integers or booleans, you don't have to write any sort of custom encode or decode function. Whereas if you were to use NS coding, no matter what you have as your properties, you would have to create your own encode and decode, and then that can get a little bit messy and kind of overcomplicated. So this looks like a lot. We're going to do this in the demo, so it'll kind of make more sense when we're doing it. But this is kind of just an example of how you would store an array of custom objects. So I want to store an array of songs into user defaults. So you'll see that on the .register for the default value, I've just used data because you can't actually pass in your custom class there because user defaults, if you try to, user defaults will like reject it when you try to run it. So then in order to store it, you need to go from your custom type. So in this case, I have song, array, and then you have to encode it to data. So then encoder over here, encoder equals JSON encoder, is just an encoder object that can encode any sort of type that conforms to codable. And then you use the encoder.encode function to encode your custom type into data. And then you can just set it as normally, and then to do the opposite operation, you just use a decoder, which also comes, if it's conformed to codable, it can decode your data. So you do the opposite thing, you retrieve .data for a key, and then you use the decoder to decode it into your custom type. So now we're going to go into the demo where all of this will kind of make a little more sense, hopefully. Okay, so yeah. Is that big enough?
Yeah.
Okay. And then I'm gonna open the demo one. So this is the demo code that was posted on Piazza. If we run it as is right now, we'll see that it's, ignore the one on the right, that's sitting, I don't want to close it because I don't want to open it again, but if we figure, so it's basically the playlist project that you guys already did, except I've added a button to the cell that you can tap on to favorite the song essentially. But ideally, if you were to favorite a song and you like go somewhere and come back, you would expect that to stay there, as well as if you were to close this app and then open it again, you would kind of expect your song to stay favorited, just because that's how you would think it works. So using user defaults, we're going to figure out how we can get the favorited songs to stay favorited every time you change to a different view or when you close the app. So if you go back into the demo code, first we're going to go into app delegate, and then we're going to create our user defaults object. Do let defaults user defaults.standard. So like I mentioned before, user defaults.standard just lets you access the standard user defaults database, and then we're going to register the default values. So you'll see that it expects a dictionary, so key value pairs, and then the way that we're going to approach saving your songs into favorites is to keep track of an array of songs that you've favorited already. So I'm going to use the key favorites, and the default value is going to be just an empty array. And I'm going to use type data because we want to actually store song objects, but since that's a custom class object, we can't directly put that into user defaults. And then if we take a look at the song file again, there's a lot of commented out code for right now that we're going to use to talk about something different later. But for now, we just have to focus on conforming our song to codable. So I've actually done something a little different, and I've made image, like the image you want to display, into a string, which is going to refer to the file name of the image in your assets. And then the reason we're doing this is because strings and bools are all conformable to codable kind of automatically. So that way you can just use a normal init function, and then you don't have to do anything special for codable. But kind of just to demonstrate, if I were to change this to a UI image, it would yell at me and tell me that I don't conform to the decodable or encodable protocols, which is what comprises codable. So we're going to come back to that a little later if we have time and see how we can write custom encoders and decoders. But for now, we're just going to use strings to keep it a little simpler. And then I've also added a isFavorite property, which is just a boolean that will tell you if a song is a favorite or not. And then looking at the actual cells of the table view, the way that we're doing this is we have a button that's kind of like the heart on the right side of the cell, and then every time you tap on the cell, so the selector, we have toggle favorite, and then if we jump to where toggle favorite is, basically the logic is if a song is not currently a favorite, you change the image to be the heart that's filled in. Otherwise, you do the opposite action. And then you also update the playlist cell to be true or false. And then we actually still have to do some stuff with user defaults now. Just doing this heart and unheart thing is just the behavior we have now, where just the image changes but nothing is actually being stored or updated. So I've actually made the view controller, the main view controller, a delegate for playlist cell, and we have a function that we're going to call every time it's favorited, and we're also going to pass in the row so we can identify what song we're kind of modifying. So in view controller, if we look at, this is the function, the delegate function that we called, let song equal songs.row basically just gives us the song for the cell that we just touched. And then we're going to set up our user defaults logic here. So we have two cases. If a song is not currently a favorite, that means by tapping on this button, we are favoriting this song. So kind of the logic behind doing this is you want to get your favorites array from user defaults, add the current song that you just favorited, and then store it back into user defaults so that the next time you access it, you have the information that this current song is now one of your favorites. So this goes back to the user defaults.value function. So we're going to retrieve from user defaults. So value for key. So if we remember, the key that I used when I registered this was favorites. And then this is, or I'm going to use as data because I stored it as a data. And then now we have to do the conversion of using the encoders to convert our data object. So stored favorites is of type data, and then we need to decode it into our actual array of songs. So now we need to kind of create our encoder and decoder objects. So in app delegate, I'm just going to declare them at the top here as well, because that way you can reference them from anywhere else inside your app. There's actually a couple of different encoders and decoders, but if you conform to Codable, they all are able to decode your objects. So we're just going to pick JSON decoder. And then inside view controller, we now need to try to encode or decode from data. So we're going to use a try statement, and then if you do decoder, there's a decode function. And then here's where you specify the type that you want to decode into. So I have an array of songs, and you want to refer to the type, so we're going to do .self. And then from is the object that you're converting from, so that would be my stored favorites that I just retrieved from user defaults. So now we have our favorites array, and the next step is to add the current song into favorites. So we can just do favorites.append and then add our new song. And then the next step is encoding this back into data and then storing it back. So it's kind of like a lot of steps. You have to decode, update, re-encode, and then put it back. But a lot of this code is pretty much the same, and you can reuse it throughout your app. So it's the reverse process. So if I have encoded favorites, I have to use an encoder this time with the encode function. So the encode function just expects one parameter, which is just the value that you're trying to come from. In this case, that's my favorites array. And then if this is successful, we're just going to use user defaults.set. As you can see, if you do .set, there's a lot of different options for like types, but they're all the same like .set. So just pick one that's value, and then I'm trying to set my encoded favorites for my favorites key. So it's really important to make sure you get the key correct. Otherwise, maybe sometimes if you misspell it by like one letter and you try to get it back, it's not going to be what you expect it because you just mistyped your key, and that's how it retrieves your object. Just make sure you have that correct. And then because we use an if let up here, so we're trying to catch and make sure that we don't go and try to do this logic if favorites actually comes back as nil, or for some reason it fails to retrieve from user defaults, because this actually returns an optional object. So one case in which this will definitely return an optional or fail to return is if this array is actually empty, which is a little bit of an odd error. But if this array is empty, this won't be successful, so this actually won't get executed. So just to kind of catch that case, we're just going to create a new array with just our new song in it. And then basically it's the same thing as encoding it before, and then just setting it to user defaults again. And then we have the opposite case in which we're unfavoriting a song. So it's almost the exact same process, except instead of adding a song, we want to remove a song. So we can do the same logic with if let stored favorites up here. And then so far we've retrieved our favorites from user defaults, and then now we want to remove this object. So if we do favorites.remove, we can use what's called a predicate, which is basically a kind of closure to kind of filter the elements of favorites and check if any of them kind of match our filter. So we're going to use the $0 to kind of refer to an element inside favorites. And then the way that I'm going to check for like equality to be like, oh, this song is the same as song as favorites, I'm going to check that the name of the song is equal to my current song's name as well as the artist is equal to the current song's artist, just because some songs could have the same name, and then you're going to remove all of them, whereas you only meant to remove one of them. And then we have to encode it back to data from song, which is basically the same logic as before in the opposite case. So this handles basically retrieving up here, and then removing, and then encoding it back into data, and then storing it into user defaults. And then one more thing that we should do is we need to make sure we update the actual song's isFavorite property. So this, I should have done this before I did all of this encoding, because we want to make sure the updated song object is the one that's stored into favorites. And then the opposite operation, we're going to set it to false when we're unfavoriting. So if we actually run this now, you'll see that all of this is, whoa, I didn't expect that to work. If we go to view controller, I don't. Okay. I don't know why it's working. It's not supposed to be working. Songs dot not favorite. Okay. Oh. Okay.
What were you supposed to add?
I was supposed to add, because when they're initialized, they're all false, and then I was supposed to like loop through user defaults and check if it's favorited or not. But they're all favorited. Unless it's running the
I believe that.
delete it. Okay. I'll run it again.
Is it still favorite?
Yeah.
Oh.
See? Okay, so it's working if you go into detail view and then come back, and that's supposed to work. Okay, I got a little confused, but yeah. So the reason why it works when you favorite it and then go into detail view and then come back is because we actually update the song object every time we favorite it, so that way when we pop back into the main view controller, we already know that we've updated the song and it is a favorite. However, if we close the app and then open it again, it doesn't stay favorited. And if we look inside view controller, the way that we create the songs is every time you open it, the songs are recreated again, and by default I've just made them all not favorites. So now we need to go through the favorites that we've stored in user defaults, that array, and check whether or not the song is already in favorites. So in order to do that, we're going to use a for loop to loop through the array of songs that we've just created. But first we should get our favorites from user defaults. So we're going to do the same thing where we retrieve our favorites. So just to go over it again, we use the user defaults dot data for key. So you're retrieving the data you've stored with the key favorites. And then you also want to convert from data into your song. So we're going to use the decoder again. and then we're going to specify the type that we want to decode into, which is song array, and then the data that we've just retrieved from user defaults. And then if we've successfully retrieved all of these songs, now we want to loop through user defaults and check, or loop through our songs and check if our favorites array that we've retrieved from user defaults is in our favorited songs. So basically all we need to do is we need to update the songs is favorite property. So we're going to check if favorites contains, where we're also going to use a similar like predicate, which is a type of closure, to check for equality. So if an element in favorites name and the artist is equal to our song's name and our song's artist, then we've found a match in user defaults. So we want to set this song is favorite property to be true. And then by doing this, any song that's a favorite, this property will be set to true. And then when we configure the cell for that row, the button's image will be the filled in heart to start off with. So if we run this now, so it already carried over from the last time that we did this. So last time I favorited gang related, and we had already established the logic to update the favorites array and then put it into the favorites array. And now that we've looped through that array, when we initialize, it sets the property accordingly. So if you go into GW, it'll remain, and then if I favorite a couple more songs and I close the app and open it again, these songs remain favorited through the user defaults, where we loop through and check whether a song is a favorite over here. I know that was a lot. Does anyone have any questions? Okay. Yeah.
Is there a more efficient way to do this than looping through everything?
Not that I can think of right now. There might be. But the key idea is that you want to make sure you check whether one of these songs is in favorites and then set the value appropriately so that the cell initializes with the correct like state of the button. So if there's no more questions on like the user defaults, I'm gonna jump into how we use like custom encoders and decoders with Codable. So before, when you guys did this project, most of you probably just set this to be of type UI image. So like I kind of demonstrated before, this will cause your conforming to Codable, which is basically an alias for both the decodable and encodable protocols, to fail because UI image does not actually conform to Codable itself. So we're just going to fix our initializer to be of type UI image instead of using the string. And then we're going to take a look at all of this commented out code that looks kind of scary. So starting off with these coding keys. Coding key is a protocol that kind of represents a type for a key that you can use. So basically this list of the enum cases is all the properties that I want this object to have, whether I encode it or decode it. So you see we have like every single property that we want for song has its own coding key. And then most of the time you just match up the name of the enum to your property name. But if you wanted to do something different, if you use also conform to the string protocol, you can also use some logic like this, and then your key name can be song name instead of just having name. And then the next thing that we need to do in order to conform to both decodable and encodable, your song object needs some initializer to kind of create the song object from when you're decoding it. So we have a required init from decoder versus just originally we just had our normal initializer function with all of the arguments. So this is basically what your code is going to use whenever you try to do decoder.decode, and then decoder.container. Container returns all the data that is stored inside your decoder for all of the keys that you specified in your coding keys. So I've stored this into values just so I can easily reference that in like the next couple lines. So then for each of your coding keys, you're going to try to decode, and then if we kind of just do this again so you can see the arguments, you'll see that it expects a type and then the key that you are decoding for. So name was a string, so we have string.self for the name key, artist for the artist key, album for the album key, is favorite for the is favorite key, and then this one's different because it's a Boolean type. And then we actually have to do something special with the images because UI image doesn't actually conform to codable. So the way we do this is kind of similar to how you use user defaults. You decode it as data, and then you kind of use this NS keyed unarchiver to cast to a UI image. Yelling at me because this should be an optional. Yeah. So now this is a little different. So you only decode if this value is present. So you're going to try to decode it, and then this will return of type data, and then using NS keyed unarchiver, which allows you to unarchive your data. If we use this again, just to see. So there's a couple ways you can unarchive objects, but we're going to use this one that expects an argument that's of type data, because that's how we decoded our image data. So then we're going to cast to a UI image and set that for our image property. And if it fails to decode something for the image data, we're going to set the image to be nil, so just no image will show up. And that's why we made image an optional property at the top, because we want to make sure we don't run into any nil errors at runtime. And then to conform to encodable, you have to provide this encode function that basically tells your code how to encode something when it can't do that by itself. So again, it's like the reverse operation. So instead of retrieving the values from the container, you're going to create the container for your values. So if you use encoder.container, it'll create kind of space for you to keep all your values, and it kind of decides how much space essentially by like how many keys you have. And then for all the properties that already conform to codable, so like strings and bools, you can just use container.encode using your appropriate coding key. But then for images, we use this first if let image because our image actually is optional, so we want to make sure our image actually exists before we try to store it into, or not store it, before we try to encode it. So instead of using NS keyed unarchiver to convert to data from a UI image, we use NS keyed archiver. So if we do this again just to see the type that it expects, so this will return data, which is what we want to encode to. Oops. And then the root object type is any. So we have image, which is our UI image, so that's of type any, and then it'll output image data, which is of type data, which we can then now use the normal container.encode function for, because data will also conform. So now we just have to fix all of this. Because we changed the init function earlier, we just have to fix all of this to just be a UI image. So all of them just have to be changed to UI images using the same strings. Make sure that fixes that one. Yeah. It's kind of tedious, but once we change all of these to BF type UI image to like match our new format for a song, it should run the way we expect it to. So the function that we're using to do the UI images is just using the image literal name, which is string, which we already had there before. Just now, instead of just passing the string, we're actually creating the image. I'm just gonna get rid of these last two songs because I don't want to type that anymore. So we actually haven't changed anything that has to do with user defaults. We've just updated our codable object, and then we have to update our configure function for the cell accordingly because we no longer have this image name property. So instead of doing that, we're just going to check if the image exists, and if that's successful, the song views image is set to the song's image, otherwise it'll just remain empty. And then similarly for the detail view, we no longer have the image name, so we're going to use the same logic to just set the image of the detail view. We build it and run. So everything works. Nothing visually actually changed, but now we've kind of gone over how you can encode types that don't actually conform to codable by writing an encode and decode function by yourself. Okay. Does anyone have any questions about codable or writing encode or decode? No? Okay. In that case, we're going to go back to this, and then...
Okay. All right. So this is our last official lecture of the semester because next week is our hack challenge. So Kevin and I are gonna briefly wrap up by talking about what we've learned in this course so far and where this might take you in the future. So what's next? So you've taken this course, you know a little bit about iOS development now. You're currently working on your hack challenge, which is a cool project. So if you really liked what you learned in this class, you can continue developing iOS apps, whether it's from your current hack challenge project or maybe you start something new. You can also join an app development related team on campus, such as app dev. The Cornell Sun has an iOS team. Fun fact, join the iOS team on the Sun. Cornell DTI and eCaft. You can also join an app development startup because there's a lot of entrepreneurial ventures here on this campus. Or if you like this class and you're interested in backend or digital product design, take another an app dev class. And they're offered every semester, and they're the same thing, 2 credits pass-fail. So we wanted to talk briefly about iOS development internships specifically. If you guys are interested more about career and industry and CS, stick around for the back-end lecture because Megan and Young will be talking about that. But basically doing iOS development at a company is slightly different than working on your own app because there's a lot of people working on the same code base. Everyone might have different style, so you'll probably learn that you have to conform to a specific style, or maybe you need to learn specific technologies that the company uses. So for example, For networking, we taught you how to use Alamo Fire, but that might not be the case in other companies. They might have their own internal networking library, or they use another one, and you just kind of have to learn how to use it. Some things that you might do while you're an intern at like an iOS role is like you might prototype a new feature, or you might actually build a feature that will be pushed to release. So there's kind of those two different things that you might encounter in a software engineering internship. And then like with regard to interviews, they're usually pretty similar to like your standard software engineering interview with like coding questions on like a whiteboard or like over CoderPad, which is like an online thing where you like video chat basically over code. But they do ask more iOS concepts versus like just your coding ability, because if you are doing an iOS internship, like they need to know that you have some experience beforehand. Yeah, so I'll talk a little bit about my 2 iOS internships. So my first one was actually I got after I took this class sophomore fall, found Bose on LinkedIn, applied, and then I had a phone interview. And they basically asked me like, oh, what did you learn in your class? Like, and then what did you work on? So I worked at a student startup over winter break and built an app. And so that's what got me the Bose internship. And I actually got to use new technology such as Core Bluetooth, which is basically like the Bluetooth framework for iOS. I learned how to connect to hardware and use like communication protocols. So one cool thing is like, I guess this speaker is now out, but beforehand I was working on like having the app communicate with the speaker over Bluetooth to like connect the speaker itself to Wi-Fi. And I worked with 2 other interns, like they were working on the Android side and I worked on the iOS side. And I guess maybe it's in the app, I don't really know, but yeah, it was basically like prototyping this concept. And then I was at Apple this past summer. I learned a lot more new technologies such as Core Data, which is what Yana briefly mentioned, which is like a database, a SQLite database on your phone, because I was working on the photos like backend, so storage and iCloud team. I learned Objective-C. So as you know, like we work in Swift here because it's like easier to read, but a lot of apps are still written in Objective-C because it's like old and it's memory efficient, yada yada. I also learned how to make Mac apps. I learned about daemons and cross-process communication, so that's kind of like low-level communication protocols, because when you're like running, for example, like your iCloud Photos library has to sync even in the background, even when you don't have the Photos app open, and that's kind of like a special priority that Apple's internal apps get. And then another thing I learned is like iCloud syncing and how that works, so I actually got to implement a new feature. Can't say what it is yet because it's not out. In Photos, hopefully it'll come out soon, and then I got to propose and design a part of a like a PhotoKit API, because that was just kind of the task that was given to me. So that was really fun. And then here's a photo of me fake presenting, and I had to black out the name of my presentation for confidentiality purposes. Yeah, it's backend because technically it's like local storage on the device is backend. So yeah, I got to like work in Apple Park. It was really fun. I had a mentor, and basically like guided me throughout the process of like either designing the API or like building out this new feature. And so it was a really great experience. And yeah, if you like iOS development, this could be you. I am going back. Thank you for asking. So hit me up if you're at Apple ever.
I'm also going to talk about my 2 iOS internships. So the first one is one I'm actually working for right now, and it's sort of weird because the way I got it was like I just messaged the person on LinkedIn and they're like, all right, let's do it. And like it's kind of weird because like their app was built mostly by contractors a couple of years ago, so a lot of the things in the app aren't like really standard. So like for example, I think almost half the app is written storyboards, which isn't that nice. So I had to like learn a bit of that. They use a lot of reactive Swift, which is like a Swift library that allows you to write Swift code in a unconventional way. I don't really like it, so I don't write it anymore. But like a lot of the code base is in that. I learned how to do deep linking, which is like if you're on your phone and let's say you click on the YouTube URL, instead of opening the URL in Safari, it goes to the YouTube app and opens a video. So implementing that feature for this app. And then last thing is like working with Fastlane and Travis, which is sort of like a tool to help you ship your apps to TouchFlight and App Store. And then my other internship was at Instagram this past summer, and here I learned how to write Objective C. So again, like Minnie mentioned, a lot of big companies actually use Objective C rather than Swift. So learning that was fun. And then Instagram also uses this open source library called Icloud, which I was able to manage 2 pods and app dev to use. And then worked a bit with GraphQL. Worked on adding new internal debug tools and A/B testing. I think that having worked at both a startup and a big company, there are like some pros and cons for each. So at a startup, I think the cons are that like again, like things aren't always done in the best way because their priority is like getting things shipped and done for like the next couple of months. Whereas at big companies, their priority is like making sure this app will still work like 5 years later on. Some pros, however, is that because there are fewer people, the amount of responsibility you'll have is like larger. So you'll probably be implementing and adding new features a lot more often. And for big companies, I think the cons are because there's so many people working in the app, the chances that you're actually going to be building a new feature that will be shipped is like kind of low. So that's unfortunate. But I think the pros are that everything is done in the best way. So like everything from like code convention to like how you ship apps to like how you test things is like everything is done in the best way. So you learn how to do things very well. And you also have like a great resource for mentorship just because like there's so many people working there. So that's also, I think, probably the biggest pro. And then here is just a picture of me with my team.
All right, so this is our last lecture ever. If you have any questions, come up and see us after class. Just kind of some reminders. So as you know, the Hack Challenge is due on Sunday at midnight. The closing ceremony is on Monday. Attendance is mandatory. We want everyone to be here so we can give out prizes. There will be food. Ignore the line about your resume. We also have a course survey, like a feedback form, that will be out after this class. Please fill it out before the last day of classes. And if half the class fills it out, everyone gets 5 points of extra credit. So great incentive. Please do it. We really value your feedback. And we just want to say, like, thank you for taking this course this semester. We've had a really great time teaching you all. And we look forward to seeing what you do with your Hack Challenge projects. All right, that's it.